Hey, welcome back. In this video, we're going to explore the structure of Nice Pictures projects. We're going to take a closer look at how blueprints are organized and how you can modify them. Before we dive into the topic, I'd like to outline a few key points. Over the years, our company has been distributing 3D assets across various marketplaces. In this period, the industry has evolved significantly and new technologies, approaches, and tools have emerged. We have actively embraced this progress, continuously integrating innovations into our production pipelines. Even though some of our projects may not always reflect the latest trends, I want to assure you that the principles and techniques I'll share in this video will provide you with a solid foundation for working with our projects in Unreal Engine. Okay, and an important thing to note is that our projects are tailored for metahumans. This means that when you receive a project, you're guaranteed that the clothing or assets included are going to work seamlessly across all varieties of metahumans. Currently, there are 18 metahuman presets, 9 male and 9 female, which are also categorized by heights into short, average, and tall. And then further categorized by weight into overweight, underweight, and normal weight. So in total, you get 18 bodies plus 2 additional mannequin skeletons, Manny and Quinn. On your screens right now is one of our latest projects whose structure we're going to take a closer look at. So let me bring up the content browser. You can see that the project is divided into several folders. The demo folder contains assets corresponding to our characters, both male and female, with their variations, as well as Epic Games assets such as animations, HDRIs, and rigs. The maps folder contains the example map of project presentation. And the last 3 folders contain materials, meshes, and textures that make up the project. The folder meshes, there are also additional physics assets and animation blueprints for post-processing. The core of a project, that which makes our characters move and look nice and allows us to control the character during gameplay, is located in the subfolder Blueprints, which is in the demo folder. In earlier versions of our products, this folder was one of the main folders along with the ones dedicated to characters. The foundation for these characters' presentation is a blueprint called BP Humans Preview. It's a successor to the Actor class blueprint, which is a generic blueprint class that can be placed into a level. A player character that has the ability to run is a successor to the character class. And this is our BP player we're going to start off with. But first, as a side note, I want to mention this editor utility blueprint that's included in some of our projects. It simplifies workflows by automating tasks and related to textures and assets. The utility contains 2 main functions. Its rename assets function that lets you quickly rename multiple files in your project, and the setup PBR textures function, which analyzes the names of the textures you select and then automatically maps each texture to its corresponding node, like base color, normal, roughness, etc. Basically, it optimizes texture compression settings according to the types of textures. And to activate the function, you simply right-click on Materials, then browse to set up PBR textures. I'll use roughness as an example. I'll switch the texture group to World and compression settings to default and save it. The settings are now incorrect. To fix them, right-click on Roughness and select Setup PBR. And the incorrect settings have been reverted to the initial settings. Bear in mind that this blueprint class is very name sensitive. If you misname, for example, base color or add extra symbols to its name, the function may not work. There's also the game mode blueprint that defines the rules and mechanics of a game. It manages gameplay elements and character behaviors. We make only one change to these blueprints. We set the default pawn class to BP player for a game character. There are also two more blueprints that control animations and are similar to the generic Epic Games animation blueprints. Next up is the input folder, which contains a set of files typical for any template project from Epic Games. And finally, the data folder that contains assets that ensure our blueprint's functionality. We're going to look at data tables and enumerators a little later. But now let me show how our blueprints work. All of our characters are essentially the same instance with different settings. In the Details panel, under Body Setup and Outfit toggles, you can see checkboxes and drop-downs that define the appearance of this character. Is asset on switches an outfit on and off, while at the same time toggling the opacity mask on and off. I can pan in on the character close enough to reveal the opacity mask that prevents the body and outfit geometries from interfering with one another. When we remove the outfit, the opacity mask will disappear as well. Now on to body setup. Here we can control the visibility of the head and hair. Also here we can switch the genders to either male or female. Human type, which could have also been more appropriately called skeleton type, gives us only two options, UE5 and Metahuman. When it comes to change in height and weight, we can run into some limitations as these options are only available for the Metahuman type. If I try toggle these options for UE5 type, they aren't going to do anything, but if I switch to Metahuman, I'll be able to change the character's physique. Now let's look at how it all works. At the heart of the performance of the blueprints are these enumerators that we mentioned earlier. First, there's gender type that determines a metahuman's gender, then height type, and then human type, which determines a skeleton type, whether it's a mannequin or a metahuman. And lastly, weight type. All of these attributes are used in character blueprints, which we're going to explore later. Now onto the two tables that dictate the blueprint's logic. The human types data table defines compatibility between body types and head types. Metahumans and our characters come with separate assets for both the head and the body. I'll head over to Meshes folder to show you the examples. As you can see, there are separate meshes for heads and bodies, and also the meshes combining the two. This allows for more flexibility in character customization. our separate meshes can be used in various combinations with your meshes to create custom characters. The same goes for female meshes. For the construction script to correctly combine a head and a body meshes, you'll need to indicate their compatibility in the data table. With outfits, things are even simpler because we sort them according to the body types they were specifically designed for. There are 20 skeletal meshes in total, 18 of them are metahuman assets, and the other 2 are for mannequins, Manny and Quinn. Each asset on this list is assigned to a specific body type in the project. We'll set humans preview aside for now, and we'll look at the BP player. Its hierarchy is pretty generic. It's the same as the third-person character. The components are the usual suspects here, such as character mesh, camera boom, follow camera. The only thing that's been changed here is the target arm length, which we brought up to 250 to zoom in on the character. We've also added a subcomponent asset to the mesh. It represents our character's asset. The event graph remains unchanged, except for those rare cases when we have to add a node called setMorphTarget for the assets that interact with hair in some way. Like, for example, when you need to hide the hair under a hat and something similar. That's the only times when we resort to this node. Other than that, there's not much to it. The main logic happens in the construction scripts, which contains only one function called setUpAccessories. Let's dive into it. Essentially, the setUpAccessories executes a simpler logic than the one we're going to see in the human preview blueprint. Let's go back to it now. So first, we need to choose our character's type. Since in the viewport we have a male character from UE5, which is also shown in the details, we have to also specify the same body type in the setUpAccessories to be able to retrieve the corresponding asset information from the data table. And after validating its compatibility with the character's body using the table data, we assign the asset to the character mesh. Next, we need to check if the asset has the post-process anim blueprint. If it's there, we're not going to need the setLeaderPost component. This logic is similar to that used in Metahumans. Some assets, like ours for example, have a post-processing blueprint. You can see it indicated by this yellow bar at the bottom, and as well as in the asset details. This animation blueprint manages body movements and inherits animations from the parent skeletal mesh. That's why there's no need for rewriting this node. But if it's an asset without the post-processing blueprint, we have to copy the setLeaderPose node of our parent element directly into the asset. After completing the animation transfer, we need to create a dynamic material instance to show the texture parameter as an opacity mask. You may have noticed in the outfits data table that each asset comes with an opacity mask. An opacity mask is a black and white stencil used to control an object's transparency. We have added an opacity mask for each body type, even though one mask can work well for different body assets. And then after creating a dynamic material instance, we have to ensure that the correct source material and element are correctly set, as these are very dependent on the character's gender. So this done, we can apply the opacity mask from our table as a texture parameter. Let's now swap out our male character for a female. I'll select F_med_normal weight skeletal mesh. And right away we can see some kind of overlaps on the body. Let's change anim class to woman to match the animations. It didn't do the trick, so in the construction script we have to select the correct body type. And now the asset fits perfectly, but we still have to set the correct opacity mask. Remember that the order of material slots differ between male and female. Let's open her mesh, and we can see that the body is the 7th element. So I'll change the index and the source material to MIF body. And that's it. Compile and save. Now we have a female game character. The same logic applies to other body types. So now you understand how we configure our characters. So let me recap. First, we select the body type, then we use the data table to determine compatible clothing assets. And finally, using the table again, we select the appropriate opacity mask. Now let's move on to the more complex Humans Preview blueprint. I'll rearrange the tabs a little. At first glance, it looks more intricate, but don't worry, I'll break it down for you. I'll remind you that this blueprint is a successor to the actor class, and it's more than enough to show the appearance and functionality of our assets. Its component hierarchy is very simple. There are 3 skeletal meshes. There are body, assets, and head. We're more interested in the modifications that can be made to the outfit and body setup variables. It's the same changes we made during instance editing. So the isAssetOn feature, represented by a Boolean variable with this eye icon, it toggles the feature on and off in the details in the level. Right now, the feature is not available, but if I enable and compile it again, the isAssetOn is available for all the characters. The body setup variables are also available except for body type, which is calculated internally. Let's take a closer look at the construction script, which typically consists of 2 functions. In some variations there are 3 functions, but the core process is the same. I'll start with the first function, setUpHuman. It's made up of 3 blocks. So the first block determines the body type we want to use in the viewport. There are 3 attributes that when combined determine the body we're going to be using. And these attributes are gender, height, and weight. These attributes are represented as string literals that are combined according to the typeset in the editor to form a unique body type identifier. I'll explain how it works. For example, changing the gender to male will result in the string literal m underscore. After defining the gender, we append the height type, average, short, or tall. And then appending the two strings results in m underscore med underscore, which is then followed by a weight suffix. Normal, overweight, or underweight. As a result, we get a unique body type identifier, which then is plugged into the body type node. After constructing the body type identifier, we have to feed it into the data table to retrieve information about the body and head meshes for these components. However, the string only applies to metahuman body types. For Unreal Engine 5 mannequins, height and weight are not factored in. That's why in such cases we have to only identify the gender. And if the human type is set to mannequin, then this type is used by the data table. Once the body type information is in the data table, we can retrieve the necessary mesh details for the body and the head. This information is then assigned to the respective components, the body mesh for the body and then head mesh for the heads. This way we assemble a character in real time during construction in the viewport. Now let's look at the hide unhide hair function. We can use this node is head visible to either hide or reveal the heads. Hiding hair is a bit more complex. Let's, for example, select the head for this male character and head over to details. You can see that the hair is under element 2 for a male character, but the female has hair listed much lower at number 6. And this can create certain challenges for us. In this function, you can see these elements are indicated here too, and then we create a dynamic material instance based on either male or female hair instance, and then we assign the isHairVisible parameter to it. So that's it for setup human function. Now let's move on to the setup outfit function. This function is pretty straightforward and should be familiar at this point. Let's give it a closer look. The function is divided into two main steps. The first step involves selecting the right outfit type for the specific body type of our character. We begin by identifying the type of the skeleton in use. If it's a metahuman, we retrieve the string created in the previous function, which is stored as an internal variable. And with a metahuman, we're concerned with whether it's male or female. Then we refer to the table where we store data on outfits and asset opacity masks for each outfit. And our first step is to assign this skeletal mesh to our assets. And if the opacity mask is valid, we can create a dynamic material instance for the body material, which is always the same for both genders. There's only one node for the material in the blueprints. And And for this node, we create the dynamic material instance. And the opacity mask from the table is assigned to the set texture parameter value. Additionally, to control the visibility of our asset, we use the set visibility function with a Boolean parameter accessible in the editor. Okay, finally we cycle through the body subcomponents. This will ensure that both the asset and the head, along with any additional components, are batch processed by the same logic. If the component is a skeletal mesh, we execute the same logic as in the player blueprint. I'll bring it up to remind you what it looks like. So basically, if our asset includes post-processing, as is the case with this project, we leave true empty. If there is no post-processing, the asset does not control its animation, and in that case, we use the setLeaderPoseComponents function to ensure it knows which pose to apply at any given time. Okay, that's it for now. Thank you for watching.